Hello everyone, and welcome to Atomic University, where we answer all your math questions and fulfill your academic needs. I'm your host, YB Normal. Let's get started. In this video, we will be going over number 63 in Finney's Calculus, Graphical, Numerical, and Algebraic, 5th edition. The problem asks us to find the piecewise defined function of f of x is equal to the function square root of 1 minus x squared when x is between 0 and 1 when x is between 1 and 2 when x is equal to 2. They first want us to draw the function, and in this video we are going to be using Desmos to do that. Part B wants us to determine at what point C does the limit exist. Part C wants us to determine at what point C does the left-hand side of the limit exist. And Part D wants us to determine at what point C does the right-hand limit exist. So we're going to go over to Desmos. And here's what the screen looks like. So in order to put in piecewise function into Desmos, we're going to do the following. We're going to put y is equal to the first part of the function, square root of 1 minus x squared. And in order to say at what part we want it to exist, we're going to do curly brackets. 0 is greater than or equal to x, which is greater than 1. And that's the first part of our piecewise function. Second part of our piecewise function is y equal to 1 when 1 is less than or equal to x, which is less than 2. Then we have y is equal to 2 when x is equal to 2. Oh, but wait, that doesn't show up on our graph. Well, whenever you have a function that y is equal to a set point when x is equal to a set point, we can just write that as that set point. And there's our graph. Let's zoom in a bit. Here's the point where we answer our questions. Part B wants us to find point C where the limit exists. Well, when x is greater than or equal to or less than or equal to something, there is a solid dot there. So we have in our first function that x is greater than or equal to 0. So right here would be a solid dot. And we also have that x is less than 1. Here, whenever you have x is less than something or greater than something, that's an open dot. So right here would be an open dot, so we won't put a dot here. We have in our second part that x is less than or equal to 1, so there's a closed dot here, and an open dot over here where x is less than 2. And then we have that x is equal to 2 at y equals 2, so this right here is a closed dot in of itself. So where does the limit exist? In order for a limit to exist, we need to have the left-hand side and the right-hand side of the limit agree with each other. So where do we see here that the limit from the right and the limit from the left agree with each other? Well, let's look. The limit coming to 1 from the right-hand side here is equal to 1, and the limit from the left-hand side of 1 is equal to 0. These 2 points do not agree with each other, so the limit at 1 does not exist. Let's look at the limit at 0. The limit at 0 coming from the right-hand side is equal to 1, and coming from the left-hand side doesn't exist. So the limit at 0 does not exist. Now let's look at the limit at x approaching 2. From the left-hand side, we have that the limit as x approaches 2 from the left hand is 1. But from the right hand, it's just 2. So those two do not agree with each other either. So what's our final answer here? The limit as x approaches c at any point on the graph does not exist because we cannot get a point to agree with itself. So let's go to part C. At what point C does only the left-hand limit exist? So we're looking at the limit as x approaches 2 from the left-hand side. So we're going this way. And we see that as x approaches 2, the limit is equal to 1. Because the function has no domain to the right of this point, then we can say that the point C equal to 2 is the only point where the left-hand limit exists. Now let's go to part D. At what point does C only have a right-hand limit that exists? Well, the only point that we see where the right-hand limit doesn't disagree with the left-hand limit, because there is no left-hand limit, is at C equal to 0. Because as you're going, x approaches 0 from the right, it goes to 1, and there is no limit from the left-hand side for it to disagree with. So the function has no domain on the left of that point, thus C equal to 0 is the point where only the right-hand limit exists. I hope this video helped. I'll see you next time.